And for section 5.3, double angle formulas. From the previous section, we're going to be using this formula. Sine of an a plus b means you take sine of the first one, cosine of the second one. If this is plus, sine leaves the sine alone, so this is still plus. And then you switch the a and the b. And then, what if a and b were both the variable x? So this one would be sine x cosine x, and plus sine of switch the x's, and it actually looks the same. So that means that sine of 2x is equal to this plus itself, means that it's 2 times sine of x times cosine of x. That formula right there is so important that you should even add it to the 3x5 card. That one gets used a lot in the rest of trigonometry and also in calculus. So notice, let's just pick some numbers and see. If you were to take sine of 2 times 5, is that the same thing as just 2 sine of 5? In other words, can you factor out a 2? No, they're not even close. But if you do 2 sine of 5 and also cosine of 5, then that is the same thing as the sine of 2 times 5. So we do need both of them. It's going to be 2 times sine of x cosine of x. Now likewise, for cosine of a plus b, so this formula, we use it a little bit, but it's not really worth remembering. This one definitely remember. Same with this one. This one in black, we're going to use it, but you don't have to have it memorized. But it goes, first of all, take cosine of each one, and then it switches the sign, and then take sine of each one. Like the last one, now I'm going to plug in x and x. So cosine of an x plus x is cosine of x and cosine of x minus sine of x and sine of x. So that means, conclusion, cosine of 2x. So this is cosine squared minus sine squared. This one also is so important that you should add it to the 3x5 card. You do need to remember that one. Now there's actually two other forms of this, because what I could do is, on this one, I could replace cosine squared with 1 minus sine squared. And that means that cosine of 2x, so once you combine these two, it's going to be 1 minus 2 sine squared of x. I could have also taken this identity and replaced sine squared with 1 minus cosine squared. In which case, it would have been 2 cosine squared minus 1. So these should also go on the 3x5 card. Now we're going to use these formulas to do lots of other fun stuff. The first one is prove an identity. So for example number 1, verify this identity. Verify that tangent of 2x is equal to 2 times tangent of x, and then it gets divided by 1 minus tangent squared of x. Now usually when I have an identity, I start with the more complicated side and then reduce it to this. But in this case, we just have these brand new formulas that have sine of 2x and cosine of 2x, and so I'm going to use these. So I'm actually going to start with the left side. So tangent of 2x. So one identity for tangent that we've had for quite a while is tangent equals sine divided by cosine. And then because this is 2x, each one of these has to be sine of 2x, cosine of 2x. And then use the identities that we just created. So on the top, sine of 2x is 2 times sine of x times cosine of x. And on the bottom, use cosine squared minus sine squared. Sometimes when you're proving identities, it's a good idea to look at what you're supposed to get. So for example, right here, I'm supposed to get a 1. So I somehow need to turn this into a 1. So now I'm going to divide both the top and the bottom by cosine squared. Or multiply by 1 over cosine squared. So if I show all of my work, it's going to look like this. Here's the overall fraction, so that's that fraction bar. On the top, there's 2 sine of x, cosine of x, and then that gets divided by cosine squared. And then there is cosine squared minus sine squared, and that also gets divided by cosine squared. And then start reducing. So this cosine will cancel one of those cosines. Okay, first of all, here's my main fraction bar. This cosine will cancel one of those cosines, but it'll still leave one on the bottom. So this will still be on the top, 2 sine of x, and now it's only going to have a single cosine on the bottom. And for this, you can break it up into 2 fractions. One is going to say cosine squared over this. The other one's going to say minus sine squared over this. So then there would be cosine squared over cosine squared minus sine squared over cosine squared. And then we're done. Because sine over cosine is tangent, which means the top has 2 times tangent of x. Just like we're supposed to have. On the bottom, this is equal to 1. And sine over cosine is tangent, and since each one of these is squared, that means it equals tangent squared. And that is exactly what we were supposed to get, so this one is complete. Then on to example number 2. Suppose that you know that cosine of x is equal to 1/5. And then find the exact value. In other words, you should be able to do this without using a calculator. Find the exact value of part A. How much is cosine of 2x? Let's see. Cosine of 2x. I could use this one, But this one I need both cosine and sine. I should use this one. So I'm going to use that cosine of 2x is equal to, using this one, is 2 cosine squared x minus 1. So that means it's 2 and then something gets squared minus 1. And what got squared is cosine of x. And cosine of x is equal to 1/5. So this is going to be 1/5 gets squared, so that's 1/25. And then times 2 makes 2/25. And then for this 1, I could get a common denominator and rewrite that as 25 over 25. And then 2 minus 25 is going to be negative 23 over 25. And there you go. No decimals, no calculator. That's the exact answer. Then for part B, how about sine of 2x? Well, with sine of 2x, there's only one choice. Sine of 2x equals 2 times sine of x times cosine of x. So right here, we could just substitute 1/5, but we also need to know what sine of x equals. Well, what I could do is draw a little right triangle, and because cosine is 1/5, cosine is adjacent over hypotenuse. So if this is the angle x right here, this is the adjacent and this is the hypotenuse. And then do the Pythagorean theorem to solve for this missing side, which I'm going to call a. So a squared plus 1 squared equals 5 squared. So a squared plus 1 equals 24. And then a squared is equal to 23. And then take the square root of that, which cannot be simplified, so it's going to be the square root of 23. So this side is the square root of 23. So now what does sine equal? So sine is opposite over hypotenuse. So now we're ready to finish this one. Sine of 2x will equal 2 times sine of x equals opposite over hypotenuse. So that's the square root of 23 over 5. And cosine is equal to 1/5. And then multiplying on the top, that's going to be 2 times the square root of 23. And on the bottom, it's going to be 25. And that cannot be reduced. And that is the exact answer. Oh, happy day. Then for example, number 3, it's going to be similar, but just a little bit more challenging. Suppose that cosecant of theta is equal to a 3. And then find the exact value of sine of 2 theta. So again, with sine of 2 theta, there's only one choice. Sine of 2 theta equals 2 times sine of theta times cosine of theta. So we'll use that formula right there. Just ignore this little blob part right there. Well, one thing to do is cosecant, that's 1/sine. So this is really saying 1/sine is equal to a 3. And then if you invert this side, it will say sine of theta. But if you invert one side, you have to invert the other side. So the right side is going to become 1/3. And then we need to know what cosine equals. So this is going to be the 1/3, but then we need to know what cosine equals. Well, we could do it the same way as last time and draw a little right triangle. Or what I could do is use this. Sine squared plus cosine squared is equal to 1. And then substitute that. Sine is equal to 1/3, so this is going to be 1/3 squared plus cosine squared equals 1. When you square 1/3, that's 1/9. Now subtract 1/9 from both sides. So cosine squared is equal to 1 minus 1/9. And you can change a 1 into 9/9. So that means that cosine squared is equal to 8/9. And then take the square root of both sides. So it's going to be the square root of 8 over the square root of 9. And then when you reduce each one of those, square root of 8 is 2 square root of 2. And the square root of 9 is just a 3. So now take this and plug it in right there. So sine of 2 theta will equal 2 times, sine is equal to 1/3. Cosine is equal to 2 radical 2 over 3. And multiply on the top, so it's going to be 2 times 1 times this, which is going to be 4 radical 2. And on the bottom, there's 3 times 3, which is 9. And that is the final answer. Okay, there are 2 more important formulas in this section. So the other 2 are that sine squared is equal to 1 minus cosine of 2x over 2. And cosine squared is equal to 1 plus cosine of 2x over 2. And yes, these are so important that you should add them to the 3x5 card, because there's going to be times in calculus when it says integrate sine squared. And you're like, I don't know how to do that. And then the teacher's going to say, you remember that formula? That's what you need. And then just pick one of those and verify that. So let's pick the first one. So verify the first one. Sine squared is equal to 1 minus cosine of 2x over 2. And I'm going to start with the side that is more complicated and then reduce it, and it'll turn into just sine squared. So starting with the right side, 1 minus cosine of 2x over 2. So then it's going to be 1 minus, and it's still going to be divided by 2. Now replace cosine squared with a trig identity. So I'm going to use that it's cosine squared. Just a moment ago, I think I might have called that cosine squared. I meant cosine 2x. Replace cosine of 2x with an identity, like cosine squared minus sine squared. So let's see, this is going to be 1 minus cosine squared. And then this will be minus minus, so that's plus. And then it's all divided by 2. Then the good news is that this right here is a trig identity. Because there's the identity that sine squared plus cosine squared equals 1. And you could use it like that, but this one says 1 minus cosine squared. So from this identity, subtract cosine squared. It's going to leave sine squared on the left side, and on the right side, it's going to say 1 minus cosine squared. So that is what I'm going to use. So 1 minus cosine squared right here can be replaced with just a sine squared. So then the top is going to say sine squared, and then plus this other sine squared, and it's still divided by 2. And then sine squared plus sine squared means there's 2 of them that are sine squared, and it's divided by 2. Finally, those 2's cancel, so it equals sine squared. And that is the end of the section. And by the way, we're skipping section 5.4, and we'll do after you're done with 5.3 and the other sections of chapter 5, then we'll go on to the problem set, which is review for the test, and then have the test. That obviously will be a take-home test. I'll email it to you, and you do your work, show your work on the page, and email it back to me.